Here's another example of a question where you're going to be asked to write the equation of the line we saw before. And if you're given a point and a slope, 2 points, you can still come up with the equation of the line. Here's another example which is very important as well, is to go straight backwards and say, if I'm looking at a line, right, can I find out what the equation of that line is? So it's no different than before. If I'm going to write this equation of a line, y equals mx plus b, I better be able to identify, like we said before, what is our m, what's our slope, and what is the b value, or the y-intercept. So I have two graphs up here already, and if you're looking at them and there's points, if there's no points identified, you can go ahead and plot some on the line. But I think in general they'll give you a couple points to use. All right, if we have the picture of a graph, it's actually a lot quicker than the previous examples, right? Because we can find b first in these examples. This is the quickest way to find b, because the b is the y-intercept, right? So, right, in this example, okay, found it. Right, so b is equal to 1, 2, 3. Easy enough. And if I want to find out what the slope is, right, we've done this before as well, so it's a kind of a combining of ideas we've done before. Nothing really new here. If I want to find the slope, right, it's a rise and a run. I'm going to travel from the left point to the right point. Right, so if I was starting at the y-intercept, I would have to take one step down. That would mean my rise is -1. And I would need to take 1, 2, 3 steps to the right, making my run a +3. And from the graph, we were able to find m and b, meaning the equation of this line should be -1/3 x plus 3. Right down here, you can play the same game. Here's our b value. It does hit the y-axis down here. So b is equal to, right, down to -2. We can still find this rise and run. So from our y-intercept to the other point on the line, we have to take 1, 2, 3 steps up, a rise of 3, followed by just 1 step to the right. It's a +1. Right. Here's our m and b, so y equals 3/1x -2. That's perfectly good for an answer. MATLAB, though, would probably want you to write this as simple as possible. So instead of 3/1, you can just write 3x -2. So we can certainly write these equations from a graph. And one last type of question we have, I'm still going to say write the equation of the line. But let's make it ever so slightly more difficult. Say so. Let's write the equation of the line that is perpendicular to the line (3x plus y equals 4) through the point (6). Okay, so this is a little bit more involved, but it doesn't change much. I still need to find m and b. If I'm writing the equation of the line, this is where my mind's at. What is m, and can that m help me find b? Okay. So we've got some ideas coming back here that we had in the last section, this idea of perpendicular, so hopefully remember how to characterize perpendicular. right? I'm going to need to find out what m is. So I'm going to need to look at this line, 3x plus y equals 4, and figure out what the m of that line is. Right? But sadly, 3x plus y equals 4, it's not even in y equals mx plus b form, in the nice form. So the first thing that I'm going to want to do is take this 3x plus y equals 4, and let's convert it into slope-intercept form. Right? We've done this before. Right, let's add a negative 3x to both sides. Right, let me separate this a little bit. Again, just to illustrate the fact that these are not like terms, variable, constant, they don't group together. Right, in this case, this one step got us there because this is just a single y. So y equals mx plus b, it's in the right form. So the slope of this line is going to be our coefficient of negative 3. How does that help us? What does it tell us? Well, it tells us that this line that we're talking about has a slope of negative 3. That's great. But that's not the line I want to write. Right? I don't want to write this equation. Right? I want to write the equation of a perpendicular line. So if the slope of this line is negative 3, right, what's our slope have to be? Right? Remember how we find that? Right? Our slope slope is negative 3 over 1. Remember, for a perpendicular line, right, we do opposite. So instead of it being negative, ours will be positive. And instead of it being 3 over 1, it'll be 1 over 3. So the opposite reciprocal. Here is our slope. Right, if this question was changed and it wanted us to write a parallel line, well, parallel would be easier because, right, if this line had a slope of negative 3, then our line would have to have a slope of negative 3 as well. We talked about parallel meaning exactly the same slope. So this one's a little more complicated. We did have to find the opposite reciprocal slope, but now we have an m and an x and a y. And we can use those. Y equals 1, m equals 1/3, x equals 6. And we can solve for b. Right? Again, we have to deal with some fractions. Not a problem in this case. Multiply across. 1 equals 6. 1 times 6, 3 times 1. This one works out very nicely. This simplifies to 2. Then we can add a negative 2 to both sides and solve b equals negative 1. All right, so a little bit nastier. We had to use a little bit of observations about stuff that we already talked about, perpendicular lines, getting in mx plus b, y equals mx plus b form. But altogether, same game. Found an m by whatever means we could, used it to help us find the b. So the equation of this line is y equals 1/3 x minus 1. All right, so there's 2 more ways this question can be asked, right? But altogether it boils down to the same question. What do you need to do to find m, and what do you need to do to find b?